Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. So in today, we are going to discuss about Introduction to Electrical Circuits. So in today's class, we are going to discuss about what is the course overview and what are the course objectives and as well as what are the course outcomes, and also we will discuss what are the various topics which we are going to discuss in these electrical circuits. So which means at the end of this class, so the student will able to have a brief idea about what is the course and what he is going to learn in this course, and what are the practical applications of this course. Like these things he will able to understand. So first, the course overview. So first let me read the course overview and so that I can explain clearly. So here this course introduces the basic concepts of electrical circuit analysis, which is the foundation for all subjects of the electrical and electronics engineering. Of course, so here, because you will get understand why this is the basic course, okay, and why it is foundation course for the all the subjects, okay, which we are going to learn in the electrical and electronic engineering branch, right? So, and of course here the very basic concepts that we are going to learn, and it includes, which means what are the basic concepts? The basic concepts includes the basic fundamental laws of the electricity, okay, like the Ohm's law and the Kirchhoff's laws, and the magnetism with an emphasis on resistors, inductors and the capacitors, which means here not only the electrical circuits, we will also discuss the magnetic circuits, and also circuits applied to alternating currents and as well as the direct current of the electrical networks, because we know already the basic different types of electrical currents are like alternating current and as well as the DC current, which means the various inputs for the circuit, right? And further this course provides the network theorems with the different excitations. Again, the excitation is nothing but the AC and DC excitation. And also we will discuss the two-port networks and the network topology to solve the real-time applications, right? So this is about course overview, which means the course overview will let us know why we are going to take this course, because this is the foundation course for all the courses present in the electrical and electronic engineering, and what are the basic concepts that we are going to in this course that we can get from this course overview. Next, the course objectives. So which defines the students will try to learn, okay, so which means what the students will try to learn by taking this course. So here, of course, there are majorly four objectives that we have mentioned, okay, and the first objective here it is the network network reduction techniques such as source transformation, mesh analysis, node analysis and network theorems to solve the different networks. Of course, here, initially we will discuss what are the various elements present in the electrical network, and by using the various elements present in the electrical network, so we will form an electrical circuit, right? Then here, why the student has to take this course means the students will try to learn the network reduction techniques, and the network reduction techniques such as the source transformation, mesh analysis, node analysis and the network theorems. Of course, here based on the requirement and based on the network topology, so the students will try to learn so which technique is most suitable to reduce that particular network, because here as you can see there are various methodologies or various theorems are there to solve the various networks, but he must able to identify, okay, so which particular methodology, okay, or which particular network reduction technique is more suitable to apply and to reduce or to solve the various networks, so that he will try to learn. And then after that he will also, the students will also try to learn the basic concepts of AC circuits for optimization of households and industrial circuitry. which means of course we know like usually in our households and many industries they use the input as an AC supply, but sometimes because we usually transmit the DC transmission lines that we can see. Okay, so because we are just converting DC and we are transmitting again, we are converting back into the AC. So what are the basic concepts of AC circuits, okay, and as well as the DC circuits, and what are the difference between AC and DC, and why we are going for the AC instead of DC. So like these basic concepts also he will try to learn from this course. And when coming to the third objective, so the students will try to learn the various configuration of the electromagnetic induction used in the magnetic circuits help in the winding of electrical machines, right? So which means of course that's what in the course overview that they have mentioned. This is the foundation course for all the courses in the electrical and electronic engineering. So like here the first objective, it can be used in many courses, and even the second objective and even the third objective also, especially for the electrical machines, because the principle behind that electrical machines, okay, to get understand the principle of operation of the electrical machine, it is very important to know the configuration of electromagnetic induction, right? So which means how the electromagnetic induction will produce and what is the principle behind that. Like this, the basics are very important to understand the principle of operation of the electrical machine. Okay, so that's why this is the foundation course. And then the final objective here it is, the student will try to learn the characteristics of the two-port network and the network topology suitable in the power system. So here, of course, here actually in the whole course, we are going to learn so many techniques, but all the techniques are only for the a specific purpose. Okay, majority is just to find what is the voltage across a specific element present in the network, or the current flowing through a specific element present in the network. So that is what actually the main aim of this particular course. So while finding the voltage across a specific element or the current flowing through the specific element, so we need to go through so many techniques. Okay, of course that is based on the type of network and the topology, okay, and based on the application and based on our requirements. So there are many criterias. Okay, so based on those criterias, so we can, the students will try to identify which technique is most suitable for a particular application or for a particular network or the electrical circuit, right? So this is all about the course objectives. Then coming to the course outcomes. So course outcomes means actually here at the end of the course, so what students should be able to do. That is what here the course outcomes will define, because the course objectives are what students will try to learn, and the course outcomes are after once you have finished the course or at the end of the course. So what students should be able to do. So that those are defined by the course outcomes. So first let us come by one. The first course outcome, the CO1, CO2, like there are usually 5 to 6 COs are there based on the content present in the syllabus. Okay, so according to this syllabus, we have framed 6 COs. So in that first CO is define the various terminology used to study the characteristics of DC and AC electrical networks, right? Which means at the end of the course, okay, so the student should be able to define the various terminologies used to study the characteristics of DC and AC electrical networks, which means the characteristics means like the behavior. Okay, so which means what are the various parameters to measure the characteristics of the AC. Okay, like what is the voltage or current. Even AC, you can see the power factor. Okay, and even you can see the phase angle, and you can see the frequency. So what is phase angle and what is frequency? Okay, and what is power factor? Okay, what is reactive power? What is active power? Like there are various terminologies that we are using to study the characteristics of the various electrical networks, right? So at the end of the course, the students should be able to define the various terminologies used to study the characteristics of the DC and AC electrical networks. Then coming to the CO2. Then CO2 is the student should be able to demonstrate the different laws and indirect quantities associated with electrical circuits for branch currents and the nodal analysis. Okay, so which means of course here, I mean, any technique, okay, so must be developed based on a certain laws, right? So first of all, we should know what are the basic laws, right? So based on that particular, I mean, those laws only are the predefined laws, so we can able to apply the technique. So that's why here, after end of the course, so the student should be able to demonstrate the different laws, like maybe the Ohm's law or the Kirchhoff's law, okay, or electromagnetic induction principle. So like the various laws are there. So he can able to demonstrate the different laws, okay, and indirect quantities, okay, not only the direct quantities like voltage and current, some indirect quantities associated with the electrical circuits for the branch currents and the nodal voltages. That's what I mean. I mean the voltage across any element or the current flowing through element. So that is what here the CO2 is defined. Then coming to the CO3. CO3 here, the student should be able to summarize the procedure for several theorems to reduce complex networks into simple equivalent networks with DC and AC excitation. So which means, of course, as we have mentioned, so there are various network reduction techniques are there, but I mean, based on if the complexity of the electrical circuit is increasing, so then we have to go for a specific type of procedure or a specific type of technique or a specific theorem, okay, that we have to use. So here the CO3 is defined, summarize the procedure for several theorems. Of course, there are several theorems are there that we will see in the syllabus. So every theorem having its own procedure. So if you want to apply that particular theorem, then we must follow that procedure. So if you want to follow, then we must know the particular procedure. So that's why once we know the particular theorem procedure, then the student should able to summarize the procedure for the various theorems to reduce the complex networks into the simple equivalent networks. Again, why we need to convert into the simple equivalent networks means, again, the same reason. Either maybe find the current flowing through the circuit or element, or maybe the voltage across the element. So that is what. Of course, and this network theorems, we can apply for both DC and AC excitation, right? Then coming to the CO4. Here CO4, here it is, the student should be able to describe the electromagnetic induction, magnetic flux, self and mutual inductance in the single coiled and the coupled coiled magnetic circuits to know the total MMF and the total ampere turns value. Okay, so which means here the concepts of electromagnetic induction principles, right? So in the concept of electromagnetic induction principle, so again some terminology it is very needed to familiar of some terminologies like what is magnetic flux and what is inductance, okay, and again in the inductance what is self inductance and what is mutual inductance, okay, and again in the in this concept, okay, so where in which kind of coils we will get the the only self inductance, and for the mutual inductance, okay, how many coils we must couple each other. So like that there are various concepts that he can the student should be able to describe at the end of this particular course. And finally, for what we are trying to learn all these concepts related to the electromagnetic induction, because of to know the total MMF, okay, that is the magnetomotive force, or in sometimes we can also call it as a voltage, and sometimes we can also call it as a EMF, okay. Of course the MMF and EMF both are different, that we will see when the concepts that concepts when we are discussing. Then coming to the CO5, here the CO5 is at the end of the course, the student should be able to develop the two-port parameters and network topology for graphical and digital representation of the complex circuits to be measured easily without solving for the internal voltages and currents in the different networks, right? Again, here the two-port network parameters are there, okay. So like maybe the ABCD parameters, H parameters, Y parameters, Z parameters, like various two-port network parameters are there. So again, these two-port network parameters are used, okay, to just reduce the complex networks into the simple equivalent networks, so that we can easily find the voltage or the current, okay, the voltage across the element or the current flowing through the element in the various networks. Then coming to the final CO, which is CO6, at the end of the course, the student should be able to illustrate the importance of the dual network for computing both mesh and the nodal analysis, right? So, of course, there is another concept like the dual networking. Okay, so I mean, after and at the end of this course, the students will able to illustrate what is the importance of the dual networks for computing both mesh and the nodal analysis. So that is about the CO6, which means at the end of the course, okay, the student should be able to do all these things which are defined by the course outcomes. Then coming to the what is that? The syllabus. Okay, so when coming to the syllabus here, first let us, going to the module 1. Here in the module 1, first, the name is Introduction to Electrical Circuits. Okay, so which means in this module, we will discuss what are the basic concepts of electrical circuits, which means some basic definitions, okay, and also some basic laws, which are the Ohm's law, okay, and also because there are various elements and what is the classification of elements, that also we will discuss, okay, based on some criteria, and even of course the voltage source is there. Voltage source is also one kind of element. So even in the voltage source, there are various types of voltage sources like the independent voltage and dependent voltage, and similarly the independent current source and dependent current source, and also the relationship between those, okay, and also in the classification we will classify active elements and passive elements, okay, and what is the relation between those, okay, like the various basic principles that we will learn in the first module, the first part of the first module. Then when coming to the second part here, we will discuss about or we will learn about the single phase AC circuits. Again, in this case, when coming to the single phase AC circuits, okay, so how we will represent the AC circuit and what are the properties of the various periodic waveforms present in the AC circuits. And there is a concept of, because especially this is only in the AC circuits, what is phase and phase angle and phase difference. These concepts also we will discuss. And also here one more concept like the what is impedance and admittance. And as we discussed here, we will discuss the power in AC circuits also, like what is reactive power, what is active power, okay, what is apparent power. Like these are the concepts that we are going to discuss in the module 1. Then coming to the module 2, it is analysis of electrical circuits, right? Of course, here also, just we will extend to discuss some more basic laws like the source transformation and, not source transformation, the Kirchhoff's laws, right? So here the Kirchhoff's laws, based on these Kirchhoff's laws and the basic laws like Ohm's law that we have discussed in the previous module. So we will start discussing some basic network reduction techniques. Okay, so which are like the star delta transformation technique. This is also one kind of network reduction technique, and mesh analysis. Okay, we can also call it as a the loop analysis, and then the nodal analysis. Okay, this is also, we can, of course, this is also a kind of network reduction technique, and also super mesh, super nodal. So these all are the basic network reduction techniques. Right. So the basic network reduction techniques we will discuss in the module 2. Then coming to the module 3, which is network theorems. Right. So of course these are also a kind of network reduction techniques, but these network theorems, of course, there are many network theorems are there that you can see here. One is the Telangana theorem and superposition theorem, reciprocity theorem, Thevenin's, Norton's, maximum power transfer, Milliman's, and compensation. Like there are so many theorems are there, but here every theorem is suitable for a particular kind of application. So here you can see the network theorems like Telangana theorem, superposition, reciprocity, Thevenin's, Norton's, maximum power transfer, Milliman's, and compensation. And so every theorem is suitable for a particular type of networks. Okay, so that's why based on the network type, so we are able to identify which theorem is suitable to reduce that particular network. And these theorems we will apply both for the AC and the DC excitation. Okay. Then coming to the magnetic circuit. So these magnetic circuits basically, all these magnetic circuits are based on the Faraday's law of electromagnetic induction. Okay, so by using this basic principle, the Faraday's law of electromagnetic induction, so we will discuss what is the concept of self-inductance and mutual inductance, and what is actually inductance means. Okay, and what is the dart conversion, and what is the use of this dart conversion. Okay, and also there are some various terminology or parameters, which means what is the coefficient of coupling. Okay, and what is composite magnetic circuits, and what is the series and parallel magnetic circuits, which mean analysis. So if you just arrange the two magnetic circuits are in series, then what will be the resultant, and are the same way if those two are connected in parallel, and then what will be the resultant. So like that we will discuss about the magnetic circuits. Then coming to the final module, which is about the two-port networks and the graph theory. So in the two-port networks, as we discussed, previously, so there are various two-port network parameters are there, which means the two-port network parameters, which are like, as we mentioned, like impedance parameter, admittance parameters, ABCD parameters, H parameters. Okay, so like various parameters are there, and even hybrid parameters. I mean, the H parameters are also called as hybrid parameters. So, what are the various parameters, and what is the interrelation between the parameters, and what is the interconnection between the parameters? Also, we will discuss here. Okay, so which means sometimes maybe ABCD to transmission, or transmission to ABCD, or impedance to admittance, and admittance to impedance, like that. The various interrelation and the interconnection also we will discuss. And also here we will discuss the network topology. So, which means how we can convert the network into the graph, and what are the various techniques to reduce the graph. Okay, those things also we will discuss. What is the incidence matrix? I mean, how we can convert the graph into the matrix, like incidence, or sometimes even what is the concept of basic tie set and cut set. Okay, so like these concepts that we are discussing this module. And also finally we will discuss the dual network concepts also. So what is the dual network concepts also we will discuss in this particular module. So this is about some basic overview about the course. So once if you will get the basic overview about the course, then we will start the topics one by one, right? So thank you.
Like, share and subscribe. Hit the bell icon for more updates.